Hello everyone, welcome to my YouTube channel Shilpa Data Insights. In this video, we are going to see the difference between an RDD data frame and a data set. In the previous videos, we have talked about what is an RDD, how to create an RDD, what are the types of RDD, what is a data frame, what are the features of data frame. So in this video, let's see what are the differences between these three APIs that the Spark provides. So we will see what are they, what is the history of these APIs, what are the similarities, and what are the differences of these APIs. So what is RDD, data frame, and data set? So all the three are APIs that are provided by Spark for data processing and analytics. And the functionality of all the three are the same. So if you are giving any kind of input to an RDD or data frame or data set, then you get the same output after the transformation is done. It is not different. So basically the functionality is the same. Now, where the difference comes? The difference comes in the performance of it and how the user write the code, whether it is user friendly or not, and what all languages are supported for RDD data frame and dataset. So we will talk about all these 3 points in detail in the next few minutes. So what is the history of RDD and data frame and dataset? So in the beginning, when the Spark was developed, the RDD was the base and RDD was a low-level abstraction of Spark. It was developed in 2011. Then after that, some kind of enhancement was done on the top of RDD and the data frame came into picture in 2013 in the Spark 1.3 version. Now, the data frame has some more advantage on the top of RDD. Let's say the data frame, the user code that you write is very user-friendly. There are a lot of optimization that was inbuilt in the data frame Spark API. And it is a high-level abstraction on the top of RDD. You can mention the schema of it. You can visualize it as a table, as like in an RDBMS, right? Then out of that data frame has some limitation because of which the data set came into place in the year 2015. So this was a history how exactly all the enhancement was done and it was improved for all the Spark APIs. So you can still work with RDD, you can work with dataset or data frame. So all these three are still available in the Spark. Now, what is the similarities of all these APIs? First is lazy evaluation. So what do you mean by a lazy evaluation? Lazy evaluation means when we call a transformation on an RDD or a data frame, operation is not immediately performed. Spark internally calls the records metadata to indicate that this operation has been requested. It performs that operation once the action is called. So it uses this lazy evaluation to reduce the number of passes it has to take over our data by grouping the operations together. So it actually reduces the number of passes while calling the transformation. And therefore, it is much more efficient while going ahead and calling an action and giving you the result. Now, what is immutability? Immutability means once you have a data set, you are performing some transformation, the current data frame or the data set is not changed. It creates a new data frame, data set or RDD. So that is immutability. Because of immutability, the data frame or data set is fault tolerant. So let's say the data is lost in any partition. So how can you recover that? You can recover it because of the feature of immutability and lazy evaluation. So you go ahead and you have your DAG, you execute the complete DAG, and as the parent data frame or data set is not changed, you can get your data back and you can do all the transformations and action and get your results as well. Now, the data frames, RDDs, data set all are in memory computation. It does not go ahead and read the data from the disk or write the data back to disk. It does everything in memory computation. And because of that, it is 10x faster than any other API. Now, we have partitioning. So as the data is growing day by day, you cannot keep the data in a single machine. So you have to distribute the data across different nodes of a cluster as a logical partition. Now you have the data, so the processing of the data happens in different partitions of a different nodes of a cluster. So this is actually a similarity between all of the APIs, RDDs, data frame, and dataset. Now, what is the difference then? The difference between RDD, data frame, and dataset is what it is. Let's see what it is first, right? RDD is a collection of elements which are distributed across different nodes of a cluster. Similarly, data frame is also distributed, whereas they are organized into named columns, like a table in a relational database. Now, what is a data set? It's an extension of a data frame. It has the features of data frame and it has an extension to it. Now, how exactly it functions? For RDD, you need to mention the program on how to do functionality. You cannot just say that what you need to do. You need to also say how to do it. So for that, you need to create a Lambda function also in order to mention how to do it. But in data frame, you just have to tell the program what to do. Whether you need an aggregation, whether you need to call an action, whether you need to do a transformation, you just need to mention that and it will do it by its own. Same goes with the data set. You just need to mention what to do to a program. Now, compile time safety. It's very important. RDD doesn't have any compile time safety, but dataset does have a compile time safety. Compile time safety means, let's say you have a data with a number of columns and you are querying on that data set and you are mentioning a column name which is not present in that particular data set. At the time of writing the code, at the time of compiling the data itself, it will mention that the data column is not present. But in case of data frame, unless and until you run the code, at the compile time, it doesn't give you any error. You have to run the code and check the analysis exception, whether there is any analysis exception on the top of that data frame or not, whether the column is present or not. So it is very much different. In data frame, you will not get any compile time safety, but in data set, you will get the compile time safety. Now, the Spark SQL. So in RDD, the Spark SQL is not supported. In data frame, you can work with the Spark SQL API. Along with dataset also, you can work with the Spark SQL API. You can do an aggregation very easily. You can do a group by, you can do a count, or you can do a collect operation. These are very easy in case of data frame and dataset using the Spark SQL API. Now comes the Catalyst Optimizer. Catalyst Optimizer is not present in RDD. So there's no optimization in RDD. You have to optimize the code in the program itself to mention how to do it. But in data frame and dataset, you get that opportunity of Catalyst Optimizer in that Spark API. How exactly the plan is created, how the logical plan is created, how it has been analyzed, how it is created into a physical plan, and then after creating a optimized physical plan, then the code is generated and it is executed. So that is a benefit of a data frame and dataset because it has a Catalyst Optimizer. Then is the language. In RDD, you can use either Java, Scala, Python, whichever language you are comfortable with. In data frame also, you can use those same language, Java, Scala, Python, and R. However, in dataset, you will not be able to use the Python or R. You have to use Java or Scala. So that is one of the disadvantages that the dataset provide. If you are pro in Python, you cannot write a code in Python in dataset. You have to use data frame in that case. Now comes is the schema. So what is the schema? So basically in RDD, there is no schema. You don't need to mention, you have to mention the schema explicitly in order to create an RDD. In data frame, the schema is structured. The data frame can go ahead and implicitly decide what could be the schema of that particular structured data. Similarly, as the data set, you don't need explicitly to provide the schema. It will go ahead and try to recognize, read your data and recognize what exactly is your schema of that particular data set. So these are the differences between RDD, data frame, and data set. Now let's see if we have three different APIs. When to use what? You may get confused, right? What exactly you need to use? Why exactly you need RDD when there are so many benefits of data frame and data set? So in RDD, your data is unstructured, right? Such as media streams or stream of text. So you can use your RDD very easily. And when you don't care about imposing a schema, such as you have a columnar format while processing the data, you need a name column, a column names basically. So if you don't care about that, then you can just use your unstructured data and use your RDD. And if you are not so much concerned about optimization and performance benefits as well, which are available in data frame and data set, for structured and semi-structured data, you can still go with RDD because RDDs are the base level and the Spark can understand it very easily and it can process the data. So in these scenarios, you can go ahead and use the RDD. But if in case you want some optimization to be taken care by Catalyst Optimizer, then go with a data frame and a data set. Or if you need a high level of abstraction, then go with a data frame and data set. If you want some action which can be readable very easily in a program code, then go with the data frame and data set. So this is the usage advantage of an RDD and data frame and data set, when to use what. It depends upon the complete use case of your project, how exactly you are writing the code as well. What are the key features you are looking for while executing your code or executing your pipeline? So that's all I have for today. I hope you have learned the new things about RDD, data frame, and data set. And I hope you like this video. So hit the like button, share it with your friends, and subscribe to my channel. In the next video, I will go ahead and create more videos on how to create an RDD, how to create a data frame, data set, and how to process these data frame and data set. Thank you so much for watching, and I wish you have a good day.